Let us study about electrical resistance of a conductor with the help of an activity. Page number 99, activity 12.2. Materials required: nichrome wire, a torch bulb, an ammeter, a plug key, cells of 1.5 volt, 4 cells. Look at this circuit. In the gap XY, connect nichrome wire. The circuit is ready by connecting nichrome wire in the gap XY. Plug the key. Note down the reading in the ammeter. It is 0.3 ampere. Now replace the gap XY. Replace the nichrome wire by a torch bulb as shown in the textbook. In the circuit, nichrome wire is replaced by a torch bulb. On the plug key. Note down the reading in the ammeter. It is 0.4 ampere. It is 0.4 ampere. From this activity, it is clear that when the nichrome wire is connected, the current drawn by the filament is 0.3 ampere. For torch bulb, it is tungsten filament. It is 0.4 ampere. We observe that the current is different for different components. Why? Certain components offer an easy path for the flow of electric current, while the others resist the flow of electric current. In the case of nichrome wire, the resistance is more. In the case of tungsten filament, the resistance is less. Thus, motion of electrons through a conductor is retarded by its resistance. A component of a given size that offers a low resistance is a good conductor. A good conductor offers low resistance. Examples for good conductors are copper, aluminium, gold, etc. A component of identical size that offers a higher resistance is called a poor conductor. Example, wood, plastic, glass, etc. Poor conductors are also known as insulators. Listen, good conductors offer low resistance, whereas insulators or poor conductors offer high resistance. A conductor having some appreciable resistance is called a resistor. What is a resistor? A conductor having some appreciable resistance is called a resistor. In the activity 12.2, we have used the resistors, nichrome wire and torch bulb. The filament used is tungsten. Nichrome and tungsten are the resistors used in the activity 12.2. Let us see the factors on which the resistance of a conductor depends. Let us perform an activity. Activity 12.3. Complete an electric circuit consisting of a cell, an ammeter, a nichrome wire and a plug key as shown in the figure. Now the circuit is ready by connecting nichrome wire. This is nichrome wire. On the plug key and note the reading in the ammeter. It is 0.5 ampere. Replace the nichrome wire by another nichrome wire of same thickness but twice the length of the first wire. Now plug the key. Note down the reading in the ammeter. It is 0.25 ampere. 0.25 ampere. It is observed that the ammeter reading decreases to 1/2 when the length of the wire is doubled. In the first case, the reading in the ammeter was 0.5 ampere. When the length of the nichrome wire is doubled, the reading in the ammeter is 0.25 ampere. When the length of the nichrome wire is increased, the resistance increases. So, the reading in the ammeter decreases. From this activity, it is clear that the resistance of the conductor depends on its length. Resistance depends on the length of the conductor. When the length of the conductor increases, resistance increases. So, the current passing through the conductor decreases. Second factor is area of cross section of the conductor. When the area of cross section increases, resistance decreases. The electrons or the charges get sufficient enough place for the movement. So, the resistance decreases. Third factor is nature of the material, whether it is a good conductor or an insulator. If it is a good conductor, resistance is less. In the case of an insulator, the resistance is high. Resistance also depends on the temperature. Resistance of a material change with temperature. Let us summarize these factors symbolically. Resistance is directly proportional to the length of the conductor. Look at the symbol. Resistance is directly proportional to the length. This is equation 1. Resistance is inversely proportional to the area of cross section. When the area of cross section increases, resistance decreases. It is equation 2. From equation 1 and 2, resistance is directly proportional to the length, inversely proportional to the area of cross section. Length is in the numerator, it is directly proportional. Area of cross section is in the denominator, it is inversely proportional. Now replace the proportionality symbol by a constant that is called rho. R is equal to rho L by A. Rho is a constant of proportionality and is called the electrical resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. It is a characteristic property of the material. The metals and alloys have very low resistivity in the range of 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. They are good conductors of electricity. Insulators like rubber, glass have resistivity of the order of 10 to the power of 12 ohm meter to 10 to the power of 17 ohm meter. When the resistivity of the material is low, they are good conductors of electricity. When the resistivity is more, they are called the insulators, bad conductors of electricity. Both the resistance and resistivity of a material change with temperature. Alloys are commonly used in electrical heating devices like electric iron, toasters. Why? Give reason. Because alloys do not oxidize, or it is called burn, readily at high temperature. Alloys do not oxidize readily at high temperature, so they are used in electrical heating devices like electric iron box, toaster, etc. Tungsten is used almost exclusively for filaments of electric bulbs. Copper and aluminum are used for electrical transmission lines. Students, please note, tungsten is used in electric bulbs. Copper and aluminum are used for electrical transmission lines. Thank you.